Hey guys, welcome to a new video. In today's video we're going to look at a Leetcode problem, and the problem's name is special array 1. In this question, an array is considered special if every pair of its adjacent elements contains two numbers with different parity. You are given an array called nums. A task is to return true if nums is a special array, else we have to return false. By parity it means if a number is an odd or even number. So they're asking us to check if adjacent elements inside the array have different parity. So every pair of adjacent elements inside the array has different parity. So let's take this example. Here in this case, these are two adjacent variables. These two have different parity because this is an even number and this is an odd number. The next pair is this. We have to check if these two elements have different parity. Yes, this is an odd number and this is an even number. And those are the only two pairs. Since all the pairs inside this nums array have different parity, we have to return true considering this array as special. In this case, you can see these two are having different parity. These two are not having different parity. So that is the case, we can return false. And a single number is the only number, so it is returned true because you can't find any pairs. Now it's a very easy problem. You iterate from starting element until the end. So in every iteration, you compare adjacent elements. And how do you check parity? You have to divide every element by 2 so that you'll get the remainder. So this element you'll divide by 2, which will give you the remainder, and this element will also divide by 2, so you'll get a remainder. And then our task is to check if both those reminders are same. If both those reminders are same, in this case both elements will give you remainder 1 and remainder 1. It means both are odd because they're having the same remainder of an odd number, so we return false. So as soon as you find two elements which have the same remainder, you can return false. And until the end of the iteration, if you haven't found any pair having the same remainder, you can return true, like in this case. So it's a very simple problem. Let's try to execute it. Now let's take the first base case. If there is only one element, you can return true. So if nums.length is equal to 1, you can directly return true. And now you can start the iteration where I will start from 0th index, and you should go only until the length minus 1, not until the end, because you are comparing adjacent elements. So you only iterate until here because in every iteration you compare this element with its adjacent element. So let me show you what I mean. So we have to do this check, right? Let's take the current element. The current element is nums of I. We have to find the remainder of this. Remainder of this, so modulus 2 will give you the remainder. Now we have to check this element with the adjacent element. Adjacent element is nums of I plus 1, and find its remainder by doing modulus 2. So here you are taking the current element and doing its modulus, and again you are taking the next element and doing its modulus. So you are checking if any case, if both these have the same remainder, it means they have the same parity, but we have to check for different parity. As those two elements have same parity, you can return false. So here, as you can see, we are doing adjacent element, right? So in the last iteration, if you usually iterate until the end, you will take this as the last element. And when you do this nums plus 1, you'll get out of bounds. So that is why you stop only till here. And in this iteration, you are comparing the next element. So this will be current element nums of I, and this will be nums of I plus 1. You don't have to iterate until the end. That is why you're doing nums.length minus 1. And if any case, like in this case, it will not return false here. So outside the for loop, you can mean that it is a special array, so you can return true. Now let's try to run the code. The test cases are being accepted. Let's submit the code. And our solution is accepted. The time complexity of this approach is big O of n, where n is the length of the nums array and the space complexity is big O of 1 because you're not using any extra space to solve this question. That's it guys. Thank you for watching, and I'll see you in the next video.